find the maximum value of n such that 50 factorial is perfectly divisible by 2520 to the power n. In other words, the question is asking us to find the maximum number of available 2520s in 50 factorial. Because let's say that in 50 factorial we have 5 numbers of, let's say for example, suppose 5 numbers of 2, 5, 2 zeros. It means this 50 factorial will be divisible by 2520 5 times, because we have this 2525 times. So the value of n will become 5. So we need to find the maximum value. This maximum value, it can be 4, 3, 2, 1, but since they are asking the maximum value, so let us find the maximum available value of 2520. And in order to do that, let us first of all prime factorize 2520. So I'll start with, let's say, 5. So 5 5s are 25, 0 and 4. I'll have 504. Let me divide this with a 3. So I'll have here 3 1s are 3, 3 3s are 9. So I'll have here 3 1s are 3 and 2 0, 3 6 are 18 and 2 4, 3 8s are 24. I'll again divide this with a 3. So I'll have a 3 5s are 15 and 3 6 are 18. Now let me divide this with a 2. So I'll have a 2 2s are 4 and 2 8s are 16. I'll again divide with a 2. So I'll have a 14. Again with a 2, so that I can have a 7 here, and then finally with a 7 to have a 1 here. So the prime factorization of 2520 will be equal to 5 times, actually let me write in decreasing order, 7 times 5 times, I'll have 1 7, 1 5, 2 3s, that is 3 square, and 3 2s here. So 2 to the power 3. So basically I need to find the total number of these prime numbers in 50 factorial in order to get 2520, and number of pairs that I can find of these things available here, that value will give me total number of 2520s. So let us start with 7. 50 divided by 7, I'll take the greatest integer here, plus 50 divided by 7 square, that is 49. After this I'll get a 0, so I won't proceed. So this is equal to, now 7 7s are 49. So this will be equal to 7 point something, and the greatest integer will become 7 plus 49, 50 divided by 49. So this will be 1 point something, and the greatest integer will be 1. So this value is equal to 10. So I have total 7s available here is 10. Now let us start with 5. So let me use some different color. So again 50 divided by 5, greatest integer, plus 50 divided by 5 square, that is 25, greatest integer. I cannot go beyond because 50 cube is 125, and 50 divided by 125 will give me 0 as my greatest integer. So this value will be equal to 10. The greatest integer of an integer is the integer itself. So 10 plus 50 divided by 25 is 2. So the integer, greatest integer will be 2 itself. So number of 5s is 12. This is number of 5s. Now let us count the number of 3 squares. So in order to do that, let us count the number of 3's first. So 50 divided by 3, greatest integer, plus 50 divided by 3 square, that is 9, plus 50 divided by 3 cube, that is 27, 50 divided by 3 to the power 4, that is 81. So that will give me 0 as the greatest integer. So I won't go beyond this. So this will be equal to, now 50 divided with 3 is equal to 3 1s are 3, 2 0, 3 6 are 18. So I'll have 2 as my remainder. So this will be 16 point something, which I can take it as 16. Plus the greatest integer will be 16. Now this is 50 divided by 9. So 9 5s are 45. So this will be equal to 5 point something, and the greatest integer will be 5 here, 5 here. In this case, this will be equal to 1 point something. So the greatest integer will be 1 itself. So this value is equal to 16 plus 5 is 21. 21 plus 1 is 22. Now I have 22 number of 3's, but in order to form 2520, I require 2 such 3's, like combination of 2 3's. So if I have 22 threes. This means I'll have 11 3 squares available, which is what I require. So this was about 3 square. Now let us find the number of 2 cubes. So first of all, let us find number of 2's in this. So I'll again divide this 50 with a 2, greatest integer. I'll again divide this 50 with 2 square, that is actually 4. Then I'll take the greatest integer of 50 upon 8. Then the greatest integer of 50 upon 16. Then the greatest integer of 50 upon 32. I cannot go beyond this because after that I'll get 0 as my greatest integer. So 50 upon 2 is 25. So 25 will be the greatest integer. 50 upon 4. So this will be equal to 25 by 2, 12.5. The greatest integer will be 12. Plus 50 upon 8. Now 8 6 are 48. So this will be equal to 6 point something. So the greatest integer will be 6. Plus 16, 50 divided by 16. Now 16, if I'll multiply this with 3, I'll get 6 3 is 18 and 4, 48. So this will be equal to 3 point something. So the greatest integer will be 3 here. And finally 50 divided by 32, 1 point something. So the greatest integer will be 1. So let us count the number of 2's that I'll get here. So 3 plus 1 is 4, 6 plus 4 10, 12 plus 10 is 22, and 22 plus 25 is 47. So I'll have 47 number of 2's available here. But what I need to form a 2520 is 3 number of such 2's. Now number of 2's is 47. So how many 3 number of 2's can I form here? So let me divide 47 with a 3. So I'll have a 3 1's are 3, 1 7 and 3 6 are 18. So I will take 5. 3 5's are 15. So I'll have 2 as a remainder, which means that I can form 15 pairs of 2's, 3 2's. If I am counting number of 3 2's available in 47 2's, I can form 15 such combinations. 15, this is 1, again I'll have 2 2's, 2's, again I'll have a 2 2 2. This thing can be formed 15 times and 2 2's as a remainder will be left. So this number of 2 3 times will be equal to 15. So I'll write it here. 15 number of 2 cubes are available here. So let us take the minimum possible value now. I have 15 2 cubes, 11 3 squares, 12 5's and 10 7's. So out of 10, 12, 11 and 15, the minimum number is 10. So number of such combination here, number of such combinations that I can form is with the least available value among these values, that is 10. So now I can clearly say that the maximum value of n, the maximum availability of 2520 will be 10.